In this video, I'm going to show you how to graph the tangent function and then how to apply the transformations to the basic function. Now recall that the tan of an angle is a ratio of the length of the opposite side and the adjacent side of a right triangle. Now in a unit circle, the value of the tangent of an angle theta is a slope of the line passing through the origin and the point on the unit circle. Now, it actually doesn't have to be on just a unit circle, but it's always going to be the slope actually. So hence the tangent ratio can be interpreted as y divided by x. So let's say that we have this length here, and we're going to call this length 1. And I'm going to draw a right triangle here, like so. And I'm going to place theta at this point, at this angle here. So if I ask you to say what tan theta is, we would say that tan theta is the opposite, which is this height, divided by our adjacent, which is 1. So let's call our height y. Then in this case, tan theta is going to equal y. So therefore, the tangent ratio is the length of the line segment. Okay, so notice it's this line segment here. So it says tan theta equals y. So that line segment, notice it's actually the tangent line. So if you recall what a tangent line is, it's a line that just touches the curve at one point. So it is the tangent line to the curve at the point A, 1, 0. So I'm actually going to call this point here A. Okay, so let me read this again. So the tangent ratio is the length of the line segment from the x-axis, which is this axis here, to the terminal arm of the angle at point Q, which I'll call this point here. So this angle theta here, so notice it's actually tan theta is y, so it's the distance from A to Q. So notice, actually, that's why it's called the tangent ratio, because it gives us the tangent line. Now, we can also designate some other points. And you'll notice that this point P here, if I draw this, and draw this as a right angle here, and now I know that this is 1, okay? And if I use a different, let's say this was y prime and x prime down here, okay, so we could also say that sine theta is equal y prime divided by 1, which means that sine theta equals y prime. We can also say that cos theta is equal to x prime divided by 1, which means that cos theta is x prime. So if I look at the smaller triangle here, it's also tan theta, which equals y over x, and in this case, since y is sine theta and x is cosine theta, I can now say that tan theta is equal to sine theta divided by cos theta, which will actually be a useful tool that we can use later on. All right, so let's take a look at how to graph tan, now that we have kind of an understanding a little bit of how to find tan. All right, so we're going to graph using a table, and I'm going to use the angle 0, pi over 4, pi over 2, 3 pi over 4, and pi. So this is not one period, well, actually it will be one period, but this is just half of a circle. So it's just like when we did sine and cosine, we rotated the angle through 2 pi. So this time what I'm going to do is I'm going to rotate it also through 2 pi, but I'm going to go through the points pi over 4, 3 pi over 4, pi, and then I'm going to skip a couple. I'm going to miss the other 5 pi over 4, so I'm going to jump straight to 3 pi over 2, and then 2 pi. All right, so at 0, so when the angle is 0, remember that tan theta, I'm going to rewrite this here, is y divided by x. So when I look at this, I have that tan theta because the angle is 0, this will have a height of 0 as well. Next, I have tan pi over 4. Now to do and understand this one, I'm actually going to go to the right triangle and use pi over 4 here. So if you remember the pi over 4 special triangle, this is 1, 1, and root 2. And if you look at the special triangle, tan pi over 4 is going to be 1 over 1. So therefore, tan pi over 4 is 1. Okay, next I'm going to go to tan pi over 2. So pi over 2 is when, if I look at my circle, this is the angle up here where it's pi over 2. So this means that my y value will be 1, but my x value is non-existent. It's actually 0. So therefore at pi over 2, the y value is undefined. At 3 pi over 4, it actually is in my second quadrant. And when I draw my right triangle, this is pi over 4 for the reference angle, pi over 4. So I still have 1, 1, and root 2. But actually going to the left, this gives me negative 1. So tan 3 pi over 4 will give me a y value of negative 1. Okay, then we're going to go tan pi. I'm actually going to go back to my unit circle again. So tan pi, this would be pi over here. So my height would be 0, and my x value would be 1. So I have 0 over 1, which means that this is going to be 0 again. Now if we keep going, taking a look at 3 pi over 2, we would notice that our y value is 1, but then our x value is going to be undefined again. Or sorry, our x value is 0, which means that y is undefined. Going all the way back to 2 pi, we get 0 again, because 2 pi should be the same as 0. All right, so noticing where these points are undefined, at pi over 2 and 3 pi over 2, what I'm going to do is I'm going to graph every 2 squares as pi over 2. And at pi over 2 and at 3 pi over 2, I have some asymptotes. Now, if we kept going, we would notice there's actually an asymptote also at negative pi over 2. Because remember, this graph is periodic. Okay, let's plot some of these points. So 0, we have 0. At pi over 4, which is this point here, we have 1. So I'm going to put a point at 1. At 3 pi over 4, which is this point here, so I'll write this down for us. So this is pi over 4, 3 pi over 4. So at 3 pi over 4, we get negative 1. At pi, we get 0. Now, knowing that this is periodic, this 0 represents this. At pi over 4, I get 1. So at 5 pi over 4, I should get 1 again. Oops, and I plotted this point a little bit too low. Just noticed. So this should be at negative 1. Now, when we connect the points, we don't just draw a straight line. It actually looks something like this because we have the asymptotes. And the graph looks a little bit like actually a cubic graph. And then continuing the fact that the tan is periodic, I'm going to go back and draw a point over here at negative pi over 4 and negative 1 and connect these 3 points like so. And I can actually keep going. So this would be again at positive 1 and then at 0. And this would give me a graph that looks like this. All right. So we can see from this graph that the period is different from sine and cosine because it repeats every pi. So I can see that from pi over 2 to 3 pi over 2 is the same graph as it is from negative pi over 2 to positive pi over 2. So since tan theta is equal to sine theta divided by cos theta from above, you can refer to the graph also when graphing. So one of the things I didn't do, I actually used the circle, the unit circle and the triangle, but we can also think of sine theta is equal to 0 when tan theta equals 0. Oops. So you'll notice, if you recall, sine theta equals 0 at these 3 points here in one period. So 0, pi, and 2 pi. So if you look at 0 and pi, we actually have the same thing. Tan is 0 at 0 and pi. When is cos theta equal to 0? When cos theta equals 0, tan theta is going to be undefined because that is in the denominator. So where does that happen? So if we draw a rough graph of cosine, we see that it happens at these 2 points. So that is at pi over 2, 3 pi over 2, 5 pi over 2, and so on. So to summarize, we can say that the domain is all real numbers, but x cannot be pi over 2, and then every pi after that, so every n pi. So x is a real number, and n is an integer. The range, the graph keeps going up and all the way down, so we say that the range is all real numbers. The maximum, there is none, since it goes on and on up and on down, has no minimum as well. The period is pi. The y-intercept, we have y-intercept of 0. And the theta-intercept, it intersects every time we hit 0, pi, 2 pi, and so on. So it hits every n pi. So we're going to say n pi. Oh, you can use x or you can actually use theta. So I've kind of interchanged them. So n is an integer. Now, one of the things that I will ask you, or you should be looking for, is also the asymptotes. So the asymptotes occur at pi over 2, and then every pi after that. So we can say pi over 2 plus n pi, where n is an integer. So note, y equals tan theta, it does not have an amplitude, but it can still have a vertical stretch. So the second thing is to find the period of a tan function. Notice that the original period is pi, so now when we stretch it, the period is now going to be pi divided by b. So unlike sine and cosine, it's 2 pi divided by b. The period for tan is pi divided by b.